Добрый день. Надеюсь, все.
Good afternoon. I hope everyone had lunch. Now Mr. Gregory Smolkin will show us how to use ProBackup. Round of applause, please. Good afternoon. My name is Gregory. I'm an engineer from Postgres professional company, and during my free time from engineering, I also participate in development of ProBackup tool, which we develop very actively and using also. The format is masterclass, but I would like to suggest certain changes. If you have questions, just don't wait. Tell me right away. We have 90 minutes, so I'm sure it's enough time. So if you don't understand something, let's solve this right away. ProBackup is a separate commercial product. No, it's open source utility, which is applicable for Postgres and is distributed under Postgres license, and it's included in our bundle. And at the same time, we include this in the package for all vanilla versions for a subset of the most popular distributives of Windows and Linux. Also, I heard there will be even a port for FreeBSD. At least somebody's trying. So accordingly, you can use this without any restrictions. This is not vendor lock. In order to make our masterclass more lively, in addition to reading of technical documents, we will try in the process to hack something, to look how it works. So we will try to dive deep in the details. So accordingly, briefly, just tell you about the tool itself. It's written on C language. Stable version is 2.27, Postgres 12. Ordinary vanilla from the standard repository. Let's begin with saying that the tool is supporting ProBackup supports many types, modes of work. Also remote mode. We can connect to a remote machine, we can start the agent will tell, the agent can understand some simple low-level commands, like create file, write something in file, give me the contents of the file, and some other more difficult things. So the agent is rather stupid, and the master is smart. This is our concept. So all backups are stored in backup catalog, which can be viewed, and accordingly the using of tool starts from utilizing of the backup catalog. In future, we will write to the file system, not to the disk. In future, we hope that S3 will become available. There are a lot of requests to store in S3. This is not at all Unix way, because it appears that it's impossible to create the copying tool which would satisfy all our crazy needs. And of course, it's inevitably a combination of different tools, because backup is quite a complex subject. They can be validated, they can be optimized, the backup process can be optimized, restore from backup can be optimized. Backups in Postgres are binary. They contain archive. So we need to work with archive. We need to show the user what's going on. So to make separate simple tools is not an option, especially to make it cross-platform. So we have a combination. The utility is written on C, and of course it is clear that it works with deep C. So we initialized. Let's try to add a remote machine. I have two virtual machines because I heard that internet is bad in here. That's why I have two virtual machines. One of those has backup catalog. The other machine contains Postgres. The database is small, just 1 gigabyte. In order not to kill my laptop and not to waste too much time waiting while it's being copied and restored. So accordingly, this backup catalog is initialized, and we will add several instances. No, actually we will add one instance because it's simpler. So accordingly, what we're doing, we create host name for the remote machine, for the user which is connected, and the directory where the Postgres is located. Yes, of course, this is a system user. So at this stage we do not need the Postgres user and its role. We're just trying to find the data in the file system, to extract PGControl file, to see what is this instance, can we backup it, to check its system ID, and to identify this instance among others. So next time when we're asked to backup this instance, we could be sure that we're backupping the right instance and not the one changed several times by user. So accordingly, at this stage everything is clear. I'm not showing to you the SSH keys installation because it's quite a simple thing, which I'm sure all of you know. In this case, we're using Postgres user, which started the cluster. Actually, not exactly. From the version 11, the Postgres supports possibility of group access, and you can create backups connecting to the user which is in the same group with Postgres user. And this way you give the backup tool just the reading access and can initialize the instance with this parameter. I'm not showing this here because this is a particular case of what we're already doing here. And also such approach will give you some more headache because restore will be more complex. You need to back up the data somewhere else where you have reading rights, then somebody needs to rename something, so it's not the scope of this presentation. So we added the node. We went to SSH, the agent started, it extracted PGControl file, found it, extracted it, and now we have the working instance. This is how it looks like at this stage. So accordingly, we have an instance which doesn't have any backups. We can look the credentials, the metadata of this instance, which is known to us currently at this moment. Most importantly, we know the metadata, we know the system ID. We know, for example, the size of xlog segment. We know this is the default connection parameters, and show config shows you the parameters which ProBackup will use by default if they are not reprogrammed somehow. Only manually, yes. We didn't reach the backup yet. Let's create it first. Yes, one more thing. In the instance, we're almost starting the creation of backup, and we do not want to backup from sub-user. Now we're approaching to the user in Postgres, because we need to connect to Postgres and to tell him certain backup words, like upstart backup, store backup, and others. So we need a role. And we need a database to connect to. It's very convenient to create an empty database and to give access just to this database. User is created with password. Access is with password. With scram mode identification, preferably. So a certain level of paranoia is very welcome in this case. So let's go to other things. This is the minimum command to create and execute the backup. As user has the backup role in Postgres, which has been pre-created in advance to save time on copy-paste. Everything which I talked about right now has been done with copy-paste before. Now we're trying to execute the backup. What's interesting in here? Backups are binary in Postgres, and they automatically mean that you need to take care of delivery of val to restore this backup. We're talking about hot backups currently, not about cold ones. As you're dealing with hot backup, you need to remove the val, which you will have to replay during the restore process in order to achieve consistency of the instance. So let's say users are writing something in the file, and then backup is taking the files away, let's say once every hour, and there is no consistency in this case. That's why we need val. Pro backup can work with val with. There are two options. It can create backups in stream mode and archive mode. We will review the simplest option, stream mode. Pro backup during the start creates a thread. It uses the thread model. It's a separate thread which connects to Postgres and tells, give me a val starting from this position. Position is given to it by start backup. And then it starts to stream to backup directory. Now we will review this in detail, the whole process. Currently we're looking at... Oh, sorry, I need to reinitialize. You're asking about backup from standby? The question is not audible. Unfortunately, there is no mic in the audience. Okay, the question is if the streaming interrupts the replication. No, it is not, because it's a separate connection. Val is distributed, and let's say 10 replicas can connect to one instance with the same interface. We're using replication protocol. We tell, please give me vals from a certain position. Postgres finds this position, and then it transfers it to you. Also, it's preferable to use slot, because the mode we're doing this right now. This is my experiment. If you simply connect using the protocol, Postgres will not guarantee that val will be still stored, which you need, because the process is long, and ideally you need to use a temporary slot. By default, we're not creating it because slot means a certain responsibility. Who knows, maybe the channel is not wide enough, maybe the machine is throttled, maybe something else. So Pro Backup does not create slots by default, but we can use temp slot command, and it will create the full backup or stream backup using the temporary slot, and this will guarantee to you that the val will not be kicked off from your feed by Postgres. The question is that we can have a situation when we are holding connect, but we cannot transfer with sufficient speed. Let's say this backup machine has only one CPU, which is very slow. And what we can do is just to support this connection and very slowly take the data. So theoretically, in such situation, we prevent it by not creating the slot. You're looking at the view PG replication slots, which shows you all the slots with their positions, which they're holding. So you can calculate the right one and to reprogram it if you need. So far, it's not very interesting. Let's have a look what happens if we use two channels. So now we have two SSH processes, each of which created agents. Pro Backup created two threads, starting to take the files from the remote machine. To each machine, SSH connect is created, and each worker starts the agent. And of course, the same is happening on the backup machine. Threads are connected with pipes to I/O of SSH connection. So we're getting sort of a pipeline with the remote machine. And this is how it works, basically. Let's have a look what we have currently at this moment. We have 3 full backups, but the machines are very weak, so even using 2 threads didn't give us much speed. So let's have a look at the main metadata from this backup. First of all, we can tell time in the instance when we can restore this backup. Let's say you created the backup at 5 a.m. It was transferred for 3 hours. It will show you 8 hours, because backup is the end point of application of files by Postgres. And after that, it will disconnect. So this is the backup mode, which is started, the file transfer mode, the time, the size, the volume of file to achieve consistency, and the compression ratio. And also start-stop LCN information, which shows from which moment the Postgres should start the val, and the point when the backup will become consistent. It has a lot of statuses. We will talk a little bit later about the validation, and we will look how it looks like. So everything which I told you, let's have a look. The last LSN was start LSN. Can I tell it backup from a certain LSN? Is such a command available? Yes, but you will need archive for this, and we will talk about it in a bit.
So here, take a look. We have the general thread, we have the thread that can read, and we have the second thread that can also take up files. The first thread is the main one, the second one is the one that streams, so currently it's selecting a socket. And the third and fourth are the threads that are maneuvering with the files. Here you can't see this. Just a second. Let's look here at the agents. Here we can see 2 agents launched, and we can look at them. We have connected to one of them, and we can see that their FIO communicate is queued up, and it is a function that the agent is waiting for in order to launch the SSH. So in essence, right now it is in standby mode, waiting for the new commands that are launched by the process on the backup machine. But because we have brought it back with a debugger, it's just sitting down and not doing anything. Because all of this works through SSH, it would be logical to give the user, you, some ability to influence with what parameters SSH is launched, because we just throw SSH to the binary, and we just people usually call us and just say, hey, launch this binary on this machine with some backup agent. And so we have special options, the SSH options, and you can add any SSH and options that SSH can take up. So for example, we had a case, because really backup takes up a lot more time. We had a case when one SSH connection was constantly terminated because it was just idle for too long, and it was being killed by a firewall. This was a case from the users. And right now it is just being launched, flagged. And they assign this flag to it, Silver Life. Well, it's like a life, an SSH thing. And so here, let's take a look at how this looks like. Well, yes, so really under the hood we have no rocket science here, just a simple SSH process. Now let's do something simpler. Let's do something like this. So, yes, no magic here. We purposefully turn off the password authentication, and you can always put it back on if you need to. We also turn compression on because we assume that the user and that the backup is already compressing it, and there is no point in compressing something that has already been compressed. And now let's hear a question. Does it open just a normal SSH connection, or does it address the screen? So if the connection breaks, do we have to do it again? Well, of course, if the connection breaks, no, you don't need a screen, but you can just leave the screen there. No, it's not a daemon. It's not a daemon. Well, therefore, yes, if something happened with the SSH connection, we cannot continue with the backup because something has gone awry, and we have to call the user to find out what happened. Yes, please, a question. And how do they find the pro backup on a remote machine? Well, they take the path to the current binary. Well, from the very start, we figure out where is our binary located, where we were launched from. Well, then we take the function that is being taken out, and the host finds its own binary. So if you just take the HTTP PBTL, and so Postgres is just looking for the PHTQTL. So the pro backup has to be in the catalog of being in Postgres, or you can use the full path. And then he said, oh, I got a full path here. Then I can use a full path on that machine as well. I've answered. Yeah? Okay, good. And there's a third option. While they're bringing the microphone over here, there is an opportunity to use the backup pass, the option, the remote pass, to which you can just say the binary is over there. Okay, can you please tell me if on the backup machine I have a 12th version of the machine, and the production one I have, for example, an older version like a 9.5? No, it's not going to work. So we need the agents to be the same version. Yes, mandatorily, because Postgres between the versions is incompatible between the older and newer ones. And when the pro backup is being gathered together, it is being put together for a very specific page format. So the page, for example, is going to be 8 kilobytes. It's going to have titles of this length and the segments of this length, and that the page in their bit is going to be of this size. So it's a binary interface of sorts, at least you can call it that. And so between the major versions, this interface changes, and Postgres itself will not allow you to stream val from 12 to 9.5 version. And we can't allow this either because we don't have the tools to, because we know we can be holier than the Pope, but it's still... so starvation is going on in the back rows, and let's hear him out so he doesn't... I have a question. We can see that SSH is launching the agent on a remote device, and then the agent starts to move files back and forth. And now you're sharing a case information with us where some client, you had a firewall terminated an SSH connection that was idle for a while. My question here is, the files at the end of the day are being dragged through the rerouting of the file flow and SSH, because if it was just simply dragged through it, then this would not have been the case. You asked the correct question. I think you have heard me being somewhat dishonest about this. I think that every thread in Pro Backup has their own SSH process dedicated to it. And so the main thread, when it is carrying out its preliminary thing, well, it was doing some service things, yeah? It was, the service process was the idle one, yes. It created its own connect, and then it forgot to close it down, and so we ended up in a situation that this connection that was not doing anything was being terminated, and we were saying, hey, your connection is dead, and let's do something with it. And the person got out of service notifications from doing nothing, and it was a bug on our behalf, and the quick workaround that we found was to use this flagging mechanism. And then we just fixed it later, and we already had no issues, and we no longer needed the flag, and we just now use it in great memory. Yes, I see another question. Well, if we're going to have so many questions, we won't have time to get through all of this. I had a question. So what about the multi-reversionism? Who is asking the question? I'm trying to see. He's here. Oh, sorry, I didn't see there. The binary backup does not know anything about the backups. It only knows its API, and sticking to this API, it'll be able to get a consistent result at the end. So it just says start backup, and then Postgres does a hidden checkpoint, and then the backup has the right to start collecting the files. It just takes them one block at a time. And thanks to this, the backup in tools does not need to know anything about the VCC because it works on the physical level. Did I answer your question? No, I was asking about something somewhat different. So let's say we have 100 various devices with varying versions of Postgres from 9 to 12. So what can we do in this case? Okay, look, just look at here, ProBack 12. Look at this, the binary, this the name. So I will need to have binaries with each of the versions and install them. Okay, I understand. Well, yes, unfortunately there is no way around this, because otherwise we would have to either code some wrapper into this, which seems to be the only normal option, where if we get the binaries still in place, just put them there and just like wrap them up, so it would be mapping these things out for you. But in the C++ binary, it's very hard to squeeze it all in there in order for all the different versions to be supported in it, because macros are already like skewed all over the versions for it to try and work across them, and for it all to be included into a single binary, I don't think it's possible. And as practice shows, this is not very necessary, because the majority of people, they have the 11th. Just use it as an example. And then some part of the people shift to the 12th. And usually the spread, well, the largest user that we have who's actively giving us feedback, I know that they have only 3 versions. And it never is the case where you have more than one instance running in the machine. So the only thing that we need to do is to keep up some additional binaries on the backup vehicles. But on the machines with the PGS, they just have their own thing going. Did I answer? Yes, but you have 5 versions. You have 8, you have 9, 9.5, 9.6, 10, 11, 12. Well, we only know how to work with 9.5. The earlier ones are not supported. Okay, we just started. This is just the beginning. And I understand that all of this looks not very fun. Oh, we are going slower. I forgot about this. Well, and you see the entire log go to waste right now. So what just happened? We opened a connection to Postgres through the replication protocol. So we're doing the same thing as fxlog is doing. Even the code that they're using is exactly the same as the fxlog. And we have slipped it, and after some time it noticed that the connection is just hanging in there with no feedback from the client, and this connection was cut. And now it has returned a message to us that the connection with the protocol of replication is no longer. And so backup ends with an error. And so here you can see everything is wrapped in timeouts, because usually, like, you would come to people who have rsync from 2005, which is somehow still alive, or that something is really stuck on the ancient system. So we really like to use timeouts around connections, to use timeouts with granting access to something, at least to some, for example, to something that we are still relying on, some interface where we do not have any power and we do not know how it does process the terminations of connections. So we're processing it, and it could not be, so we try to work safely. Okay, so let's try to compress something, because I did not see a single backup that would be kept in an uncompressed format. And so many people ask questions, why the further the backup gets, the harder it gets. And the thing is, because the files are sorted out by size, and it seems that I think we have to stop doing this because people are getting scared. They're saying, oh, it's getting slower and slower with every second. And what is happening right here that is interesting right now is you can see the agent has taken 100% of the CPU, and I'm going to just replay this here. Look. And we have launched the process of compression. And if prior to this in CPU we were limited by SSH because SSH is the encryption, right now we are starting to be limited by the agents because we are going through compression. And this, in essence, is very good. I mean, bad. But from one side, it's good because when SSH is the limit, it's a very sad limitation. The maximum, what we can do through SSH, according to what I tested, and I did some simple benchmarks through SSH without any additional tuning, using just the standard ICE 256, we were able to pass a gigabit through it. And this is for one flow, and they're linearly downloaded if you have enough disk space and if you have enough bandwidth to scale them up. So you have 5 gigabits flow, but in the same place, in the very same flow, the same base backup can give you 5 gigabits. So SSH is a real penalty, 5-fold penalty to how much bandwidth you can use it. So it's definitely a very comfortable transport system, but it's not does not come free, and you have to take that into account. And so by default, the flag compress is just a thumbnail. And when we're talking about compressing, we see algorithm slip, and I'm not going to be recording this because there's a mistake there, but we see the slip happen and the compress on level 1. So right now, we only know how to work with the slips, and for compress levels, we only know how to use the defaults. The very original, initially only the first one is launched because the file shows us a normal combination of speed and the compression rate. As you could have well understood, because this is from the general, and this is a Postgres machine, and because we were limited by the CPU there, and we were limited there because we were pressing hard there, and if you're asking, let's have a look at this, why not? And let's do this. And here we can see the agent. Are we connected to the right one? What is it doing? Nah, it's the wrong one. Okay. I did not guess correctly. Okay, let me try now. Well, yeah, I got throttled here, so. You can't see from over here. Okay, fine. Just, you will have to trust me that it is limited by the CPU because it is currently in the slip mode. Okay. Let me try and catch it. Nah, didn't make it in time. Okay, yeah, so it's basically sitting there in a slip. We have a patch to support LSD4, which is much faster at this. Well, of course, it gives us a worse rate of compression, but it works much better, much faster. Now, what happens next, at least at this stage? When the backup is complete, here you can look at what's happening. Here you can see all the files have been downloaded. And we're starting the Vesta backup. The backup is successful, after which we forcefully validate what we have written down. So when we are copying the files, we're counting the checksum for them from the CRC32 rolling checksum, and then we write it down into the file. And each file, we have a huge file with metadata, and each file has their own checking sum. And when we do the backup, we double check that the fact that everything we have written is indeed correct. Well, it's actually fairly demanding to try and validate everything after each backup. So if you are brave, if you're cunning and wise, then you can turn it off in order not to waste your time. Yes? The checksum is for the entire file, of course. Well, first off, they're there either way. Then if the file's checksum doesn't match, that means you understand that there is a problem with the file, that the file is damaged. And, really, if we make it to the validation here, and, we're not making it on time right now, but when the validation finds that the checksum, that the file checksum does not align, it's trying to figure out what blocks broke down, and it's trying to figure out what particular block has a checksum issue. So technically you can try to fix something, but this is already for people who are true fans of this. So what do we see here now? We have had a look at the compression. What can we see? This was without compression. Okay. So the fourth and the fifth backups, starting from the top, they were made while using compression. They're 10 times smaller, and there you can see how different they are from the third one. And the ZT ratio is the coefficient of compression, because usually it's the synthetics. It's very good at being compressed, and so instead of 1.5 gigabytes, we only have 150 megabytes. And of course, in terms of time demand, it is far more demanding. Although there are separate cases, in case you have a very weak channel, but you have a lot of CPU, then you will be able to get a significant win in time just because you are putting less data through the channel, or, for example, you have very sad hard drives. And so you can evaluate the efficiency of compression based on this parameter. Okay, so compression is all nice and well, but we would like to see something incremental. Excuse me. Okay, we definitely know that it was validated. I'm going to repeat, what is the difference between done and okay? Okay was validated. Done was launched, and I'm just going to show you right now. Done was launched with a flag of no validate. And I think I needed to mention that, yes. You understand that the done status is the fact that the backup was completed, but it was never validated. And okay means that it was validated, and that it was validated, that everything is fine. And so we're going to move to incremental backups. Because, actually the most difficult part, the biggest question of value is a very difficult one because of the demands that it puts on your infrastructure and the management of this entire thing. Because right now, at the stage that we're at, for us, in order to carry out these kind of backups live in the stream mode, for us, all we need is an SSH access. So we can back up the machine that we're backing up to the machine from the machine that has Postgres. So via streaming, we take all the values, we get the stream of the backup. We also call them remote backups or autonomous backups because you cannot use the point recovery system on them. You only can set them to the same time that is set in the recovery time. But you don't need to think about the archive. And we have one mode of incremental copying, which is very well fit into this entire system. You do not need to unfold the archive for this. This is the incremental mode and the delta mode. Yeah, well, okay, let's take everything unnecessary out of here that are going to just be interrupting us. Yes, therefore, so you can control your level of logging both as in the console and in the file. And so by default, the level of info, let's just put it as log. So you noticed, yeah? We're still doing the backup on stream, but now it's a delta backup. And now let's have a look at how does this look like. And yes, I have turned on the more detailed logging, so now you can see how the workers are starting off, how the workers are shut down, how you can see the transfer of the backups, and it's already complete. Oh, no, it's not. Yes, it is. Okay, so what is happening here right now? Please notice that it's much faster than the full backup. Now, what is this caused by? So what happened here that allowed this backup to be carried out so quickly? Well, we've seen the workers launched, and the workers, the remote workers, the agents, they were given the beginning of the LSN of the previous backup of the parent backup, so the second one from the top here you can see, and they had to copy to send to the backup machine all the blocks that have an LSN, and so in each data file and in each page of the Postgres file you have the LSN, which have the LSN higher than the beginning one, so then the one we have here, the parent one, so larger than it. Because I did not launch any bench, so the data has not been altered, we have ended up with a fairly small backup, so nothing changed in this regard. We have 32 megabytes of values, and 32 megabyte of values is because Postgres does a forceful rotation of this, and when you tell it to stop backing up, well, let's try to add some load to this, and I'm going to get a Geekbench onto this, and we're going to try and see how does this all look like. So the database is fairly small, so 1.5 gigabytes is like it's nothing. So if you would be doing this on a file level, then this is where your incrementality would end, because, for example, now the Geekbench is launched, now we see 600 transactions being carried out. Therefore, in each, well, you know that Postgres has gigabyte files, which are, you have a gigabyte here and 2 files there, one is a gig's worth, another one 500 gigs. Well, it's not exactly like that, but you understand that if you were granulated on a file level, then we could not be even talking about any sort of incrementality. But let's see what we end up with. Yes, so we have a bit of a competition for resources going with Geekbench for 70 seconds. And it just launched copying. Okay, but copying has been complete. It's ready. And now here, pay attention. This is an interesting part. What can we see here? The pages with zero sum. So we can assume that this is an index, because for index files with relations, it is very characteristic such a large allocation of empty blocks. When the BD tree gets split, there is a fairly aggressive this, the empty place is very aggressively relocated, which is why we get the empty blocks. And here we have seen this relocation take place because our backup was launched while the data set is being changed. And as you can see, our backup has become significantly larger, meaning that now it's 140 megabytes, yes, without any sort of compression this time, but it's clear, right? The compression, well, would have 10 megabytes, right? If the ratio is approximately the same, so because we have a per-page approach to the incremental copying, we, instead of getting the same 1.5 gigabytes, we were able to get away with 150 megabytes. And this is it's a good result, but it has its own drawbacks. And what is the evident drawback that it has? Because we are forced to reread the entire PG data. So in the Delta mode, we are loading up the reading to the Postgres instance, which is same as the one that would be given to a full backup, because we have to reread the entire thing. On the other hand, this has an interesting benefit that we're able to also simultaneously validate all the pages, because the Pro backup validates the instance, and we are going to be speaking about it in more detail once we get to the validation. Now, okay. So, because we understand what we needed to input during the runtime while we're actually considering the page, we're able to get small backups, but we're forced to recalculate the entire instance. And these are the pluses, the drawbacks and benefits of the Delta mode. Well, maybe. So, for example, you don't like to constantly carry these options around with you because they're not comfortable, because they take up your command line, it's not comfortable, it's not nice, and you can use the set config command, and we already know the command show config, and there is also the command which allows us to change this. And what is this caused by, really? When you are trying to develop a cross-platform utility, very often when you're reading some guides, they always tell you create a config file and put these and these values into it. Or here is an extract from the file, copy and paste into the config, and then let it work. You need to make sure it's not always comfortable, because sometimes it won't work. For example, on Windows, because you need some sort of a cross-platform guarantee that would allow you to make sure that it works everywhere. And so it's much more comfortable to change the config through a separated command, and to also view it through a separated command. It is very comfortable. You don't need to go through all the files, and you don't need to download separate editors to each of the devices to manually change it all, constantly afraid that you have misplaced something, to spoil your eyes looking through the lines of text. So any changes of the configuration happen through the set config, and the display of the configuration happens through the show config, and this is our credo. And here you can look that, you can see that the log console is actually placed. Okay, good. And we spoke a lot about the backup, so now let us go ahead and try to recover it. I mean, like, the most important part of any backup is recovery. So let's see what we can get done. Here we have a fairly large amount of backups now, and we're going to try and recover things from it. Now, how does recovery take place? Now, in our case, I understand that we, for example, say something went wrong, or you have a new instance that is being launched. But in our case, we're just going to emulate this situation. We're going just to emulate the cluster being stopped. Yes, well, let's just drop everything that was built up there. We click the current date, and we're going to launch the recovery process. Now, if we just launch the recovery without actually pointing out any particular backup, now by default it's going to be using the latest one, so the very first one from up top. Now let's see what will come of us trying to do this. Now what happened here from the very beginning, if we look at it? We have created an agent. The agent has checked that the target value is empty. He had a look at the mapping and the table space of the external directory, and now is trying to validate the parent chain. And because every incremental backup, it really is nothing without the chain of parent backups that it is relying on. So in our case, the backup, the very first one from the top, the one that we're covering right now, its recovery means that we are trying to recover its full parental backup. On top of that, we're trying to get the next delta, and only then the backup that we're trying to recover. So we're trying to recover the entire chain here. No, of course not. No. If we would be doing this manually, no, it would be horrible. Immediately, everybody would shoot themselves and all the feature that they have as soon as they'd have to do that. And so they say instead of recovering the table space, you just need to remap this. And if they are remapped, you just recover it from the same place as you could before.
Remapping of table spaces, I will not tell you in detail because it's just there and just works. Then what happens? We validated the whole string. We understand that it's integrity, and then we validated each file. Now we see the updated files. Maybe we even should change the log level, which is too low. Now we need to validate the val in order to be sure that Postgres will be able to read this val segment and will be able to apply it. So we can just use the same mechanism which is used in Postgres during the reading and parsing of val. So it takes the page, it checks the checksum, it checks that it's correct, then it goes to the next page, checks that it's available, that it's there, the checksum is matching, and the page looks fine. So now we're doing the same what Postgres does, just without using val, because it's impossible without a catalog. Now we're starting to restore everything. We start agents. We create the directory. And so we started the recovery from the backup of the files. What we should look at. We're counting the number of bytes which we transferred. We also check the time. It took 20 seconds, which is slightly faster than the Delta backup. And in process, we're also calculating the efficiency. And we know that the target PG data size is 1,554 megabytes. We're comparing it with the number of bytes which we transferred, and the efficiency is 93%, which means that, for instance, we have block number 5, which is in full backup, and when we took full backup, it changed. So we created a new Delta backup, and the block number 5 again went to the next backup, and to the next, and to the next, and to the next. So when we restore it, every time we have to write it there, because currently we're too stupid to make it in an optimal way. Actually, we could have copied it just once, but so far it hasn't been realized. So in order to enable the user to understand how efficient the changes distribute in his backup and how efficient this ratio of incrementality, let's call it this way, we calculated in the process. Let's say if we had 2%, it would have been terrible. It means that you installed one database, backed it up, then deleted it, recreated it from scratch, and then created another incremental backup. So a lot of data would have been rewritten. But here, because the changes are dotted, the efficiency is quite high. So for each file on the remote machine, maybe it's too much, but in theory, if after restore this machine will crash, at least you will have a guarantee that everything which we've written is dumped to the disk. And by default, we consider that this guarantee is required to you. Let's give it to you. And here we can see that fsync took more time than the actual copying of data. It copied within 20 seconds, and sync took 25 seconds. So when you're restoring something, you probably are in a rush, and we can skip this step and to make no sync. If you're in a real rush, you can even switch off the validation. To flag no validate, it's the same flag as we had in backup. Wait a moment. No sync, no validate. Let's start. We skipped validation. We skipped this all these messages about the null pages. And we jumped directly to the copying of files. This is the agent working. Another agent, and we completed within 20 seconds. And also it gives a warning that because we asked so, the synchronization was not done. But the efficiency is almost 2 times higher in this case. Next item. Maybe it will be interesting for the users of Ubuntu. These are external directories. We've had a big problem actually because the distribution of Postgres, of the packages, it was organized in a very peculiar way. The config files have been distributed. For example, log are in var logs, and other things are in other types. And probably you need to back up your config files. Can we restart this process? Yes, of course. The most interesting part, I missed it. It will be interesting if not. Okay, it started, it works. Let's have a look into the log. Okay, we started. We are ready to accept connections. So what happened here? Of course, we copied all the data files, we put val, and at this point the pro backup work ended. Then Postgres starts. vals are enough to reach the point of consistency, and when it reaches this point, it becomes available to serve connections. This is the particularity of stream backups or autonomous copying. If your RTO is not high enough, for example, you can lose data within 2 hours. You can perform autonomous backups every 2 hours, and at least you will be guaranteed that you have restoration points every 2 hours. And you do not need to think about archive, about SSH keys. And for instance, if you have 200 instances, you need to generate them. In this case, you don't need to think about all this. The requirements to the structure are much lower. You do not need to maintain the archive, which is also useful and convenient. Okay, we will talk about retention later. In our retention policy, you can set different policies of retention, but a little bit later we will talk about it. This is the particularity of Postgres 12. Recovery conf was destroyed, and actually this is very bad. Actually, in the past, it's bad for the backup tools developers, because before you had a file where you could store some conditions from which the user would like to restore, to backup, to put flags from which the restoration would happen, and then you guaranteed that this file would be destroyed, and this condition will not be transferred to the next backup. But currently, this file doesn't exist anymore, and we consider that user will put his own parameters. For example, restore on the 9th of May. We put in the conf file this parameter. Then you forget about it, the tool comes in, it backs up the instance, then you want to restore it, and you put not 9th of May, but some, for example, immediate parameter. And in this case, either the backup will not work, or, for instance, you will put time, but to the config file, which is read first. So backup is not determined. And when we encountered this problem, we created a support for it. We put everything in backup recovery conf and included in PostgreSQL auto. But again, we don't have a guarantee that this auto file did not come to backup from the instance, and just in case we need to create it. Because if Postgres finds out that some file is missing, it will crash. So this file needs to be created. So a lot of complication arise because the community killed this file. So if next time we change the configure parameters, it will not disappear from there. But what is the guarantee that something will be rewritten? You came with other parameters. So this point is required only for restoration. Yes, it's not even backed up, just it's created every time, just in case to avoid compromising the user. Which config? What are the guarantees? Then some other config will not be included. What are the guarantees that the Postgres will not start with the inclusion of other config? You can put these parameters for the start as pro backup completes the work with instance, and the backup tool took this information and then its work is done. There is no guarantee that Postgres is not being started with some strange flags or doesn't reconfigure your parameters. So in order to make your job the most determined, we have to use such steps. There is no other way, unfortunately. Yes, you can do it locally, of course. We're reviewing the local backup. Okay, let's talk briefly about the directories. The Ubuntu users, their config files are somewhere else. Let's create files, for example, 1, 2, 3, 4, 5, 6. And we have a file A. We can make delta backup. It can be delta, why not? And let's indicate the external directories which needs to be connected to backup. Let's start. Sorry, 113. Let's start again. We back up the directory with the same rules which are applicable to all other files. If you have an hierarchy, then we will save it. We will calculate the checksum for this file. We will remember the permissions. We will stamp them. But as we do not allow the start from the root, we will not save the user, the owner. Permissions we save. So accordingly we can restore and see that it arrived. We start the restoration, same as the last time. Well, the time is limited. So pro backup divides all the files to data files and no data files. During the moment of parsing of the paths, we look at the file carefully and we understand either it's data file or not. Incrementally, it's block by block. We're trying to read it like this to look for checksum for LSN. No data files, such as VM, FSM, log files, dumps. Data files are backed up incrementally on the level of file. So, accordingly, if we do not change the external directory, we will create another delta backup. It will not copy it again, it will just save in the metadata that this file didn't change. Let's see what's in there. Yes, the size is 0, same as it was. Now we're approaching to archive. All these things. Okay, question. LSN restoration, marked transaction, and time. Yes, this is point-in-time recovery, which demands for archive. Now we're looking just at local backup, autonomous backup. So each backup is a point in time, and it's some XCID. If we look into the metadata of backup more carefully, let's look, for example, the last backup. What do we see? We can see that it has stop LSN, where it stops. There is a recovery seed, where it will stop. And also recovery time, which is restoration of this particular autonomous backup, which will lead this cluster to this inconsistent. Inconsistent cannot be backed up. So what you're saying means point-in-time recovery, and it automatically means archive. And now we reached finally the archive, and we are almost out of time. But I still have 5 items to talk about, and also questions. Well, okay. Okay, let's talk at least about the archiving briefly. Let's switch on archiving. We set archive command. Archive push, we put the same credentials like remote host, remote user. Let's use compression. Let's start. We create it. We started. Let's put some load right away. Okay, the load is applied. And archive expands our possibility for incremental copying, which enables us to try to execute the reserve backup in page mode. Let's look how it looks like. Okay, it failed. How do you think why? Actually, this is okay, let's do it again. We can put this also in config. Let it be. So, why do you think this page backup failed? What happened in reality? Let's look in show mode. Page backup connects and says start backup. It receives LSN. Then it goes into archive and tries to find all the vals from the start LSN of its parent to its own start LSN. As we switched on the archiving, after we created the last delta backup, we have a gap between the parent and the first segment which went into archive. And this is what this mistake is about. It tells us that parent backup A61 and the next it cannot find. So in this situation we will create another incremental backup in delta mode, or just make one-time full backup. all incremental backups are all page by page. They go into val, into archive, and they're looking for information about changed blocks. So instead of like delta to read through the data, it looks for this information in val, because val contains the information which block changed. The size will be the same. And if your incremental backup have different size for the same condition, then something is wrong. The backups must be absolutely identical, because the changes are the same. They must be identical. Just the way of obtaining the data is different. We look into the block and to understand if it changed or not. And in this case, we go into archive. We start to parse all the val segments between start LSN of the parent and its own start LSN. We create a map of the blocks which changed and take them one by one. So if your instance is 1 terabyte, the backup will be much faster. Let's say 2 bytes only changed, 1 page changed. Delta, to understand, will have to read through these 5 terabytes. And this one will be able just to parse through vals to find exactly the page which changed. This is very convenient, especially for users with big instances. In parallel, the PG bench is running. We have 64 megabytes of vals. It took 37 seconds. It took more time because PG bench was running. Let's start without it, just to look how it is. The second important thing which archive gives to us is that we can, it parsed a lot of val files, compressed. Then it gives us the time which it spent, and then it transfers exactly the pages which changed. So, in addition to page backup, archiving gives us possibility to create backups in archive mode, when we do not need to open connections for replication protocol to stream val. Because why do we need to store val, the same val twice? We have the same archive, and we can rely on this archive to achieve consistency and point-to-time recovery, what you've mentioned. The archive gives you the possibility to get zero data loss if, for instance, something is switched on and you cannot afford replica. You can stream the vals directly to archive. Then backup will execute the role of replica as well. So you have a guarantee that nothing will be lost. Let's say 2 blocks are damaged. Can I restore these blocks without stopping the server? No, unfortunately you cannot, and I can explain why. You need to take the initial block. First of all, you need some backup. Second, you need archive, and thirdly, you need to know which block is damaged. You need to take this block and to apply the changes to this block. And only Postgres can apply vals to blocks. It's impossible to extract it from it and to make it externally. We have certain prototype of such a feature, but it's very preliminary. We give it a page, for instance, 2 days ago. Then we have restart command and tell it to apply the vals to blocks. But it's not exactly what we need. And unfortunately, what you're saying is theoretically possible, but nobody created it so far. But the SQL Server and Oracle has such a feature. I can do it page by page. I work in Microsoft as an engineer. That's why I'm asking such question. SQL Enterprise Edition allows me to restore a certain page. It will look through the transactional logs and without stopping Enterprise Server, I have Enterprise Edition. So without stopping it, I can achieve such a result. Unfortunately, Postgres cannot do such things. It doesn't have such functionality. It cannot apply vals to pages. Postgres cannot do this, and externally also it's currently impossible. We tried to approach this problem. We achieved certain results, but I'm not very happy with it. To be honest, it's not elegant, to be honest. It has a lot of overhead, it's very slow, it works, but it needs to be approached some other way. Okay, we have an archive, super. We learned to create backups, and now we can also create them in archive mode. We can create backups in stream mode, in archive mode. Archive mode is good because we don't have to duplicate the val, which is stored in archive separately. Okay, we touched on archive. Now let's talk about what's inside the archive. Archive is a directory with val files, and it's not always clear what is the content of these files. In our show command, we have archive flag, which gives us some understanding what's in archive. So we're looking what's in there, and we show some meta information about what we found. And in our particular case, we can see one timeline with number 2. We see parent timeline, minimal segment, maximum segment. The total size is 81 megabytes. Compression ratio is 8. We calculate, we know the size of segment. And accordingly the status. What we can understand out of it. We can understand, for instance, that status 1, we know for sure that between the minimum and maximum segments, everything is fine. Nothing was lost. Let's try to lose something.
Then we'll see the segment disappear. Which segment don't we like? Let's say we don't like segment number 6. Boom. Now let's have a look at what's happening. So we have straight away noticed that we have a segment missing, and now the timeline has a degraded mode, and we can see what exactly has disappeared. This feature really appeared as a result of the fact that people are always asking, do you have a backup? Yes, we have a backup. Do you have an archive? Yes, we have archives. But they do not know what is inside those archives. Maybe half of it is already lost, the second half is broken, and nothing is clear. It's just a random collection of files, and what can we do with it is unclear. And our archive is our approach regarding how to make this entire situation more presentable. Now, let's just be more attentive to this. We have the JSON format. It just has more meta information in it, but unfortunately, we can't just transfer all of it. Now, what can we do? Now, to each timeline, you need a full list of backups. I don't think that was the best idea with all the information. Now, what do we know? Well, from the beginning, we can show you what bit on this timeline was lost. We can tell you, starting from which segment you have a gap and ending it, and where on which segment does this gap end. And this is useful and good, especially if this segment can be returned to its original place. Then the status can also be changed back. Okay. Well, you can get it wherever it goes, but well, regarding guarantees, now we're going to talk about the validation of archives. Well, just coffee break is starting. You can go to it. Yes, unfortunately, our time is up, and Grigory can spend an eternity talking about backups. And of course, backups are interesting, but I would suggest to those who want to go to a coffee break, and for those who want to stay, for those who want to know more about the subject, to come to Grigory and to talk to him personally. And can I just stay here and just continue talking? Yeah, for half an hour. If you want to go, no, I don't have 15 minutes. Okay, then it's better to approach him individually and to speak to him separately. Thank you.